Okay, well, welcome back. We had a little delay in finishing up here. Okay, so what happened was video stopped. Okay, technology, part of science, what I teach the kids all the time. Things don't always go the right way. That's why you have to go back. So what we talked about before is that what we want kids doing is doing a lot of things that get them to think, all right? There's not always a step by step by step by step. There are some steps, but sometimes you have to do a few steps, go back. For instance, ask questions, develop models. 5 minutes into it, you might figure out that maybe this wasn't the best way to come up with a model. Go back, ask some more questions, do some more planning. So ask questions, define the problem, what are you looking for, developing models that are going to show what we're doing. Okay, so posters, videos, graphics of any kind, graphs, actually creating a model, building a model of what something would look like. Plan and carry out the investigation, collect data, use your math. Oftentimes you're going to have to use math in science. Math, as we tell the kids, is the language of science. You have to know your math in order to come up with computations, graphs. Do you have to be the best mathematician? No, but you do need to know your math to do science. Explain. What did you get from that data? How did you come up with a solution? Why did you come up with a certain solution? What did that data show you? Did you come up with a solution? Was the data what we would call inconclusive? Kids understand that. We can put that into everyday language where they understand. And it gives them permission to make mistakes. We want kids to be able to understand. You can make mistakes, go back, ask new questions, do another plan, come up with some new evidence, different evidence, compare the data, look at what you have in front of you. We always want to remind kids that scientists do this. This is what scientists do. They don't go 1, 2, 3, 4, 5. They're always going back, retesting, reinvestigating, re-questioning, and questioning each other. All right? That's how scientists work. They don't just take information without asking questions. So let's talk a little bit about what do you need to do. So when you're teaching a unit, you're teaching lessons, you want to make sure, in my case, I always make sure they have 3 components. They have a visual component, which I often use to draw them in, short videos, graphics, any type of visuals will draw kids in. Quick experiment will draw them in, quick activity, quick demonstration will draw them in. You want them asking why. Okay, so you have visuals, you want to have a hands-on, inquiry base, project base, whatever those terms are that we're using. You know how that goes, you change up, but basically we want them digging in. We want them feeling things, touching things. That's what's going to help them to remember. Tactile, okay? And then a literacy component. And we know that from the extreme weather unit that you did through the DESE, that was literacy-based. However, that's great. Literacy in science gets them asking questions. And there are certain experiments, simple experiments you can do with kids. So for example, if you're doing weather, one of the things you can do, okay, is straw, some water, sand from the beach, some rocks. Okay, have the kids show what happens with wind, with erosion, with the tides. When you combine those things, such as in a hurricane, you get storm surge. What happens? Very simple. Okay, get the straw, and blow it. The kids can see. They can see the sand moving in, moving out. Get some rocks. Why are these rocks rounded? These rocks I took from the beach were rounded. These are some other rocks, not from the beach. They're very jagged. They have flat sides, jagged sides. Why do you think these rocks are different? Why is one so rounded? What's causing that to happen? Kids can figure that stuff out. They can think, but you have to let them do the work. All right, other thing, been around for a long time, tornado in a bottle, water, dish soap, shake it up, mix it around, put a few items in there. I have some wood matchsticks, pieces of plastic. You can put glitter in there, it works great. Okay? Show the kids the vortex. What happens to materials that are taken away, that are sucked up by the wind, okay, over land, over water. It can be a water spout. And what happens to those materials that get sucked up, okay? Well, they can picture that. They can think about that as a wind vortex, moving along, pulling all the loose pieces of wood and anything else that's not nailed down or in a spot where it can really be held in tight. And even then, sometimes the power of the wind can take it away. All right? Something very simple. A plate, straw back, okay? Have the kids blow on it. Nothing much happening. Take a couple of pieces of cardboard, a couple of slits in the paper plate, put them in there. Now have them blow. Game changer. What's happening? Why without these slips of cardboard in here? What caused that to happen? Let them ask questions. I keep going back to that. It's very important. Talking about extreme weather, which was the name of the unit that you did this year. Talking about air. Okay, air contracting, expanding. This is a great experiment here. Take a bottle, glass bottle, put it in some hot water. The air inside the bottle begins to expand. You put an egg on top of it, a hard-boiled egg. It literally gets sucked in. So it's like a stopper on here. I cannot pull this out very easily. Water's cooled off a little bit. I can get it out, but it's going to break. Okay? Kids want to know why. Why did that happen? Say why. All right? These are the types of things that draw kids in. Going back to the water, talking about sand. Where does sand come from? Kids want to understand that sand actually came from broken down pieces of rock, erosion. What about the shells? A couple of seashells. Kids are familiar with these. What happens when the organisms living inside of them die? And these seashells are being pulled back and forth through the tides, being banged up against rocks. What do you think happens to these? Do they become part of the sand? Ask. Let kids think about things like that. So I've shown you a few experiments. Some of the great books out there by Paige Keeley. She's got 6, probably 8, maybe 10 books out there now. Giving the kids problems, letting them investigate, come up with solutions. These are awesome. Okay? These are just 2 of them. What are they thinking? This is great. These are all wonderful for elementary age kids, because what are they thinking is very important, because there's a lot of misconceptions out there. And those misconceptions that I learned through this fellowship that I did over the past few years get carried. They get carried from preschool through 2nd and 3rd grade, through middle school, through high school, the same misconception. So when we grab kids when they're young, when they're asking that question that we hate to hear, why, that's okay. We want them asking why. Picture Perfect Science, another great one. Inquiry in Action. And these can all be tweaked, made more age appropriate. Maybe you need a time factor that's involved. So 3 things. You need to have something that's going to draw them in visually. You need to have a literacy component, and you need to have an inquiry-based, project-based, hands-on component. So, for instance, if you want to draw them in, so we're talking about the extreme weather unit that you did, show them something like this about hurricanes. It's going to pull them in. This is going to be the wow factor. These are the types of videos that draw kids in, to make them want to find out more about weather and hurricanes. Okay, there are a number of different great websites, which I will give you in the fall when we do our professional development after school. We bring in teachers that are going to be introducing science back into the elementary classroom, which I'm very excited about. 3rd and 4th grade teachers, you're going to be the first ones to implement our new Science Scopes curriculum, which is excellent literacy component, visual component, and hands-on inquiry, project-based, whatever the buzzword you want to use. It gets kids kids thinking, it gets kids working, it keeps them involved, it makes them want to know more. And ask you questions you can't answer. That's okay. That's okay. Kids need to know that we don't know everything. And that's why we have scientists, because if we knew everything, then we wouldn't need to investigate. So there are a couple of websites. For the weather website, there is Weather Whiz Kids. There's a number of different experiments on here, as you can see, hopefully. Easy to do, easy experiments. Most of the resources are easy to get. The only thing I would caution you is try them out, see what kind of problems you might run into, and you can tweak them before you actually give it to the kids. But don't give them the answers. Let them figure it out. So I look forward to seeing everyone in the fall.